In this notebook, we're going to take a look at the NumPy support in Numba. So this is the second notebook, which is named 1_numpy.pyimb. Numba is designed to be used with NumPy, so there are some standard functionalities. So you can use NumPy arrays as arguments, and then you can create ufuncs. We'll see later more in details about that. And then a large subset of NumPy functions are available in no Python mode. However, Numba never calls the NumPy libraries themselves. It knows how to replace the NumPy functions that are used inside the function that we want to optimize with lower level libraries like BLAS. And so what we are doing is we use NumPy functions here to describe to Numba what's the computation that we want to achieve, and then Numba knows how to implement that without actually relying on the NumPy implementation. And doing this, what it also does is combines more calls together more so that it's passing through the data just once instead of doing multiple time a loop through all of the arrays. Okay, so let's take a look at another example. So this zero clamp function takes an input array X and a threshold. Whatever value is lower than threshold is set to 0 here. And so we are doing a loop on the full length of an array. So we wouldn't be able to do this in Python, in pure Python, of course. And then we have a conditional. And all of this is passed to the Numba just-in-time compiler in no Python mode so that it can be sped up. So we can call it on an array that we just created. And the first time that this is called, Numba creates an optimized version of the function. And we can call the same function with different input types. So for example, you see here we have an integer and two kinds of float 32s, a contiguous one and a strided one, where you see here we created a contiguous array and then we have a view of every other element specified with this. And we can time them with the magic function time it, and we see that they have different performance, that because even if they have the same number of elements, they have different input types. And Numba stores attached to the function the compiled version of all of them, so that if the same type is called again, there is no need to recompile the function, but the optimized version is directly used. And we can also compare with NumPy, and we see that in this case, the performance is pretty similar. It's pretty similar. You see here we are about 14 microseconds and 10 for the float 32. And we have similar performance. This is 12 microseconds. It looks like Numba is faster in this case. Probably there is some optimization trick that's using, but it's very similar. Now, let's take a look at ufuncs. So ufuncs, or universal functions, are like most NumPy functions that they can handle operations on any kind of array. For example, you have the cosine function in NumPy. If as an input you have a number, it's just going to take the cosine of that number. If you have an array, or if you have a matrix, it's going to do the cosine operation of each element of that. So it's like has an internal looping, let's say. And you can do the same with Numba. So you see now 0 clamp X is an element of the array. So it's not the whole array as it was before. Okay, so in fact, you see here that if X is below the threshold, it's just returning a single element 0. Okay, but instead of calling just in time, we call vectorize, and this is going to handle any kind of input. And so now it basically works the same as it was working before, but it is more general because this can also handle more complicated inputs. For example, two-dimensional or three-dimensional arrays. Okay. Okay, then let's take a look at another example. So we have another example where we have this function that computes some error. And we call the mean function, which is a numpy function. And this works fine with Numba in no Python mode. So you see, this is the other way of optimizing a function. So instead of using the decorator, you can call the JIT function and pass as an argument to the function the function in pure Python that you want to optimize. Okay, and that's so we have two versions, so one in NumPy and one in Numba, and we can compare the two. Okay. Again, here, one of the optimization that Numba is able to do compared to NumPy is to avoid having temporaries. So temporaries is one of the worst problem with NumPy. So whenever you have some chained operations, NumPy has to create different arrays for each operation. And so this is kind of tricky because sometimes you don't understand how much memory you are using. Instead, Numba can avoid that problem. But we see in this case, performance is very similar.